Yes. So today we are going to work on, we are on unit 1 and 2 combined still, point 4. Okay, and our concept for today is graph systems of inequalities. So graph systems of inequalities. Yes.
Just a quick question about the homework. If one period turns in homework but another period doesn't, how does that work on grade?
They just might have more homework points. Yeah, at the end of the unit, everyone will have turned in the same amount of assignments.
Oh, okay.
Yeah, so I'll even it out. And I always collect the review, if that helps you. Actually, sometimes honors turns in more or less homework than regular, so those are the only ones that aren't collected the same amount, maybe. Okay, so graphing systems of inequalities, okay? For example, number 1. Basically what we're doing today is the same thing as what we did on objective 3. We're just, instead of graphing one inequality, one line, we're going to be graphing multiple lines on the same grid. Okay, so if I ask you to graph x is less than 6 and y is greater than -1 on the same grid. Now, if you have several different colors of pens, I would recommend that you use them here. You don't have to, but it's helpful. Okay, so I am going to label my lines. Okay, I'm going to make this a pink line, and I will make this a green line. Okay, if you are not using different colors, you are going to need to label your lines, just so you know which one is which. But I am using colors, so it makes it a little bit easier. So just make a grid, do the best you can. It does not have to be perfect, okay? How would I graph an x equals line? Is an x equals line going to be an up and down or a side to side? Up and down. So put your first point where x is equal to 6. And is this going to be a dotted or solid line? A dotted line. So do your best to make this straight. Now, before you do any shading, you're going to write yourself a note, okay? You do not want to shade. Do not shade until all equations are graphed. Okay, we are not going to shade. We're going to do the shading at the end. So do not shade until all equations are graphed. Okay, do not shade until all of the equations are graphed. So we have my first equation graphed. How about the y equation? Is that going to be a side to side or an up and down? That is side to side. So put your first point where y is -1. We just said it's going to be side to side, and since it's not an equal to, this will be dotted as well. Now, there's a couple of different ways that you could do shading, okay? The first way is to actually shade every single graph, okay, and then figure out where the intersection is. I'm interested in where the shadings kind of overlap each other. Instead of shading all of your graphs and figuring out which is the darkest place type thing, I would do it this way. I would start by figuring out for the pink line, where is x less than 6? Is that on the left or on the right of your line? On the left. So x is less than 6 on this side. So instead of shading, I would actually cover up. You can do it with a Post-it or like just with your fingers. Cover up what you're not going to shade. Okay? Then for the green line, would you shade above or below the green line? Y is greater above. So I would not shade below. Then whatever's left behind is where your shading should go. Okay? It just makes it a little bit neater, and then you can tell like what your actual answer is instead of just all this crazy overlap. Okay, so, and you can even do it like with your fingers. Like, okay, I know I'm not going to shade there, and then I know I'm not going to shade there, and then shade what's left behind. Okay, next one. So this should be relatively simple for you. Okay, you've done stuff like this before. This is exactly what we did on Wednesday, except that it's with more than one equation. Next one, I'd like you to graph the system -x plus 2y is greater than or equal to -4. and the equation x is greater than or equal to y. Okay, negative x plus 2y is greater than or equal to negative 4, and x greater than or equal to y. So again, I'm going to use two different colors, so I'm going to actually rewrite this one a different color. Negative x plus 2y is greater than or equal to negative 4. Can I graph this as it's currently written? Not really. Okay, what would I have to do first? You need to get y by itself, so how would you start to get y by itself? Start by moving the x, so add x to both sides. That would leave you with 2y is greater than or equal to, which should go first, the negative 4 or the x? The x. So x minus 4. Then to get y by itself, divide every single part by 2. Don't forget, you do have to divide the x as well. You can't just leave it by itself. These cancel each other out. So it leaves us with y, oops, sorry, forgot I was doing colors. Y greater than or equal to, how would you write x over 2 as a fraction? 1 over 2. Remember, there's actually an invisible 1 there. So you'd write it as 1/2 x minus 2. Now, for the other equation, is x greater than or equal to y? Is that in a graphable form right now? No. Not really. Okay, what you actually need to do here is you need to switch everything. Okay, you need to switch both sides. So we don't need to subtract or anything like that. We can just literally flip it over. So this is going to become a y, and an x is now on the left, or on the right side, excuse me. If you flip it over, okay, the open part of the alligator was aiming towards the x. So don't forget that you also have to flip this part. Okay, so this actually becomes less than or equal to. Now I can actually do my graph. So here, if I draw this, let's see. So where is my first point going to go for the pink line?
0.
Not quite, for the pink one.
Oh.
The pink one, it's at negative 2. You're almost there. You're just doing the wrong one. Then how do I get to the next point? How do I move to get to the next point? Raj, how do I move to get to the next point?
Up 1, right 2.
Yes. Stop talking. So up 1, right 2. Okay. Should this be a solid or a dotted line when I connect them?
Dotted.
Solid, because it has a line underneath it. So make that a solid line. Make it as, straight as you can. Doesn't have to be perfect. And then where would I make my first point for my green line? What's the actual y-intercept there? A 0, okay? You can add 0 or multiply by 1 in any equation and it will not change it. So if there's nothing there, it means it starts at 0. So start at 0 to get to the next point. This actually has a slope of 1, so that means you'd go up 1 over 1. Would this be a solid or a dotted line? Solid, because it has a line underneath it. So do your best to make that a straight line. Okay. Now, to figure out where your shading goes, for the pink line, should you shade above or below the pink line? Y is greater above or below? Above. So I'm not going to shade under here. Okay. How about the green line? Excuse me. Should I shade above or below that line?
Below.
Below. So I'm definitely not shading in there, and you just need to fill in what's left. Now, I will, just a word of caution. A lot of times these will create either a little slice kind of like that, or it'll create a triangle once we get to 3 lines. Do not always assume that that is going to be where you're going to shade. It does not always work that way, okay? Like 80% of the time it does, but it's not a rule. So be a little bit careful when you're doing that, because I don't want you to make mistakes just because you're being lazy and didn't look. Okay, next thing I'm going to ask you to do, I'll switch pages. Okay, next thing we're going to work on is write, for example number 3, we're actually going to go backwards, and I want you to write the system of linear inequalities. Write the system of linear inequalities represented by the graph. Okay, so this time I'm going to give you a graph and I'm going to ask you to write the equations. Okay, so go a little bit backwards here. So write the systems of linear inequalities represented by the graph. So we're going to draw a graph. So my first line is going to have a y-intercept at -3. And to get to the next point, we're going to go up 3 over 2. It is going to be solid. That's kind of straight, kind of not, sorry. My second line is going to have a y-intercept at +2. To get to the next point, I'm going to go down 1 over 2. So, like right there. It is also going to be solid. I will turn this in just a second. And my shading is going to be over here. So what does a linear equation look like in standard form? What kind of standard form does a linear equation have? What's the standard, or what's the slope-intercept form of a linear equation? Y equals mx plus b. So I'm going to just write these as y equals mx plus b equations. So for the pink line, for every line, you can always start with a y and an x. Okay, you can't put anything else in. For the pink line, is it shaded above or below? So it's shaded above or below the pink line?
Below.
Below. So that means it is a less than. Is it solid or dotted? Solid, so that means it's a less than or equal to. Now, when you're writing an equation, you actually need to go a little bit backwards. You always want to start with the y-intercept, which is what letter in y equals mx plus b, which is the y-intercept?
The B.
The b. So the y-intercept for the pink line is where?
-2.
At -3. So that means at the end of the equation, we're going to write -3. To get from one point to the next, how would you move? Thomas, how would you move to get from one point to the next?
Down 1 over 1.
No, we're on the pink line.
Yeah. There's no.
To get from here to the next.
3 over 2.
Up 3 over 2. So to get from here to the next point, you'd move up 3 over 2. So just write that in as a slope. Leave it just like that. Now if we look at my green line, again, I'm going to put in the y, put in the x. Okay, is the green line shaded above or below it?
Above.
Above, so that means it's a greater than. Is it solid or dotted?
Solid.
Solid, so that means it's greater than or equal to. For the green line, what is its y-intercept? It's supposed to be at +2. So at the end, you're going to put a +2. And what is its slope?
Down 1 over 2.
Supposed to be down 1 over 2. So down 1 over 2 would be written as what? -1/2. Okay? That is your system of linear inequalities. Okay? You're not going to have very many of these on your homework, but I know for sure that there's one in your test, just like this, that you're going to have to go backwards and write the system. Okay, next thing I'm going to ask you to do for number 4 is to find which point lies in the solution set. Which point lies in the solution set of the system? And the system of linear inequalities is y minus x greater than or equal to 3 and y less than or equal to 5. This is going to be a multiple choice. And your choices are 1, 2, 5, 6, -3, 2, and -1, 7. Which point lies in the solution set? So when you graph two linear inequalities, what you're basically creating is something called a solution set. So there's two different ways you could do this. One is you could graph it and then figure out where the overlap is, and then figure out all these points, which one would be in that overlap. Okay, so that involves some graphing. Or does anyone think they know another way that you could figure out this problem? Any ideas? Tyler, what do you think? No, not set them equal to 0. You could just plug things in. Okay, so I could plug in these points and figure out which point works in both equations. Okay, which one would you want to plug into first, the first or the second one? Probably the second one. Why would you want to plug into the second one? Because it's easier. Okay, look at this. Which of these has a y value less than 5? Does A work? Yes. Does B work? No, so automatically that's not an option. Does C work? Yes. Does D work? No, so at least I've eliminated 2 options. So now I'm done checking this one. Now you just have to plug in x and y and see which one works in the first equation. So if you plug in x and y, is 2 minus 1 greater than or equal to 3? 2 minus 1, is that greater than or equal to 3? Raj, is 2 minus 1 greater than or equal to 3?
No.
Are you sure about that? You look not so sure.
I don't know, you're confusing me.
2 minus 1 is 1. Is 1 greater than or equal to 3? No. You said
Seven,
yes.
no.
Oh. You're talking so much, I can't understand what you're saying to me and what you're saying to Colton. Okay, now, just because you've eliminated all the other choices does not mean that the one left is your actual correct choice. You still need to check it just in case you made a math error somewhere. Okay, so check this one. Is 2 minus negative 3 greater than or equal to 3?
Yes.
Yes, 5 is greater than or equal to 3. So yes, C is the correct answer here. So you really just have to plug things in. If you're not good at plugging things in, you could technically graph and then figure out where they cross each other. Okay, I have 2 more for you. Last thing that we're going to do is graph the following. Graph the following inequality systems. Graph the following inequality systems. If I ask you to graph x is less than 6, y is greater than negative 1, and y is less than x plus 2. So this time we're going to move from just graphing 2 to graphing 3. If you have it, you should probably use 3 different colors. If you have that many. If you don't, then you just need to label your equations, label your lines. Remember, you do not want to do any shading until the end because it makes it a little bit easier to do it all at the end. So x is less than 6. Is that an up and down or a side to side line? Is an x equals line an up and down or a side to side? An up and down. So put your first point where x is equal to 6. We said this was an up and down, straight up and down line. So, and it is, since it's not an equal to, you do need to make it dotted. Okay, how about the green line? A y greater than or equal to greater than negative 1. Should that be an up and down or a side to side line? Y equals line is a side to side. I have a poster for you just in case you have trouble remembering. This is also a dotted line. And then finally my orange line, where should I make my first point?
2.
A positive 2, where y is equal to 2. How do I move to get to the next point from there? Up 1 over 1. Okay, so the slope there is 1 over 1, so up 1 over 1. And this is also a dotted line. Then to figure out where you shade, I'm going to use that post-it cover-up method. Okay, for my pink line, would I shade on the left or on the right of the pink line? Where is x less than 6? To the left of the line or to the right of the line? To the left. So I'm going to cover up where I don't shade. Okay, how about the green line? Would that shade above or below the green line? Where is y greater than negative 1? above. Okay, so I'm not shading there. Greater than negative, yeah. And then how about for the orange line? Would I shade above or below that? X is less than, so that means you shade below. So that'd be under here. So in this one, you're going to end up shading in this little triangle. Okay, but I don't want you to always think that that works because sometimes it doesn't. So you do actually have to do the shading. You can't just randomly do the triangle. Okay, and then the last one I'd like you to graph today. Last one, I promise. Y greater than or equal to X. I'd also like you to graph X plus 3Y is less than 6, and 2X plus Y is greater than or equal to negative 3. So Y greater than or equal to X. X plus 3Y is less than 6, and 2X plus 3Y, or excuse me, plus Y is greater than or equal to negative 3. So, is there anything wrong with this first one? Can I graph Y greater than or equal to X? That one's fine. So, I'm just going to rewrite that one and I will graph it in just a minute. Okay, next one, X plus 3Y is less than 6. How can I change that to be a graphable form? What do I have to first do? Start by moving the X, so subtract the X from both sides. If you subtract the X, we got 3Y is less than negative X plus 6. What should I do next, Isaac? Not quite. I want to get Y by itself. So the 3 is attached to the Y. How do I undo the attachment from the Y? Right, so divide 3. Okay, if you divide 3, that gives you Y less than, what's the coefficient attached to this X right now?
1.
There's a 1 there, so that'd be negative 1/3 X plus 2. Sorry, I'm kind of running out of room a little bit. And then your last equation is a 2X plus Y greater than or equal to negative 3. What do you have to do for that one? Keyshawn, what would I have to do for this one? Move the 2X, right? So subtract 2X from both sides. That would leave you with Y greater than or equal to negative 2X minus 3. Now that you have all 3 of those equations in a graphable form, you can graph them. So for the pink line, where should I make my first point for the pink line? What's the y-intercept for this pink line? 0. Okay, so make your first point at 0. How do I move to get to the next point? Up 1 over 1. Okay, should this be solid or dotted? Solid. We're not going to shade just yet. How about for my green line, where should I make my first point? At positive 2, where y is equal to 2. How do I move to get to the next one? Slope there is down 1 over 3. This one should be dotted because it's just a less than. And then finally for the orange line, where should my first point go? At negative 3. And then Sonali, how do I move to get to the next point? If I start at negative 3, how do I move to get to the next point? We're graphing.
Down 2 over 1.
Down 2 over 1, thank you. So down 2 over 1. And is this one going to be solid or dotted? This should be solid, okay, because it has an equals underneath it. Now, last thing you have to do is shade. So for the pink line, should you shade above or below the pink line? Y is greater, so you would shade above. So I'm going to cover up what I'm not shading. Okay, for the green line, do I shade above or below that? Less than means you shade above or below? Less than means below, so I'm going to cover up there because I know I'm not shading there. And then for the orange line, do you shade above or below it? Above. So you will end up coloring in this little triangle in here. Okay? Are there any questions on graphing? So this is exactly what you did on the lesson before this. You're just adding more lines. Okay? You do have homework this weekend.